All right, 9.1 radian degree measures. So we're going to start with what is a radian and what does it measure. So you can always read the definition. I'll read it off and then we'll make more sense of it here. Radian is a measure of a central angle theta that intercepts an arc S equal in length to the radius r of the circle. So what does that mean? So 1 radian is the equivalent, as I draw this poorly here, if this is 1, this is also, this length is also 1. All right, so 1 radian is roughly the same distance as 1, r is equal to 1. Okay, that's the whole purpose of it. As you keep going around, of course, it'll keep increasing. Or if we go a little less, it's going to be less than that. We're going to go through on the next slide different radians in terms of pi. All right, we got going around. So right there is pi over 2. Okay, why? Let's think about it. So pi, if you did pi divided by 2 in your calculator, it would be like 1.5 something, right? Remember how we said this is going to be about 1 right here, 1 radian of an angle. So it's going to be it's a little beyond 1, right? So pi over 2 right there. And we get to pi, 3 pi over 2, and 2 pi. So keep in mind, when you're between 0 and pi over 2, I should say in between, not or equal to, you're in the first quadrant. Between pi over 2 and pi, you're in the second quadrant. Between pi and 3 pi over 2, you're in the third, and then 3 pi over 2 to 2 pi. You are in the fourth. Okay? Or equal to, that's just a greater than sign. So keep that in mind when you're given different radians, then you can estimate about where you're at as long as you know your fractions. So now we're going to find coterminal angles. So what does that mean for us? Well, 17 pi over 6, if you might notice, is more than 2 pi. And we don't have 2 pi in this space right here. So we need to find a radian that is actually in between 0 and 2 pi. Because what will happen is, as we keep going around, we got 0, we got pi over 2, pi, 3 pi over 2, 2 pi. And then as 2 pi increases, we just keep going around and around in a circle. Okay? So we want to find out what value will correspond with 17 pi over 6 if it was actually within 0 to 2 pi. So how are we going to find that value? Subtract 2 pi. We need to get a common denominator, so it's going to be 12 pi over 6. Subtract, you get 5 pi over 6. So that is the coterminal angle of 17 pi over 6. Now we have negative 3 pi over 4. When you're negative, you're going to be adding 2 pi. So when we're adding 2 pi, get a common denominator, and you're going to get 5 pi over 4. Okay, and if we sketch them, I'm going to do in red 17 pi over 6. 17 pi over 6 would be around 1 time, and then round to 5 pi over 6 right there, because it's in between pi over 2 and pi. And then we'll do the same for a negative 3 pi over 4. So negative 3 pi over 4, we're going backwards. I'm going to go in blue. Is approximately right there. Okay. So we have 2 angles in radians, and what we're going to do is find the complement and supplement of these. Okay. So we're finding the complement and supplement. Remember, complementary. If you remember in degrees when you did this in geometry, complement is up to 9 degrees, but in the case of radians, it's going to be pi over 2. supplementary will be adding up to pi. So how are we going to find the complement and supplement of 2 pi over 7? So what we got to do is we're going to take pi over 2 and subtract 2 pi over 7. Get a common denominator, so I'm going to multiply this one by 7 over 7, so 17 pi over 14 minus 4 pi over 14. Subtract, you get 3 pi over 14. So 3 pi over 14 and is the complement of 2 pi over 7. Now for the other one, we got to find the supplement, so it'll be pi minus 2 pi over 7, common denominator, 7 pi over 7 minus 2 pi over 7 equals 5 pi over 7. Now for the other one. Now you might notice that 3 pi over 5 is more than pi over 2. So there is no complement. So we're going to do pi minus 3 pi over 5, which there is a supplement, as a matter of angle to this. So we subtract it, get a common denominator. 5 pi over 5 minus 3 pi over 5, get a common denominator, subtract, get 2 pi over 5 is the supplement. Or angle. Now we're going to talk about converting between degrees and radians. And we are familiar with degrees, probably more so than radians, but you should be okay with radians by now anyway. So if I'm giving you degrees and you need to convert to radians, you need to multiply your degrees by pi over 180. Okay? Then simplify the fraction and you got your radians. Radians to degrees, take your radians and multiply by 180 over pi. And that will get you a simplified answer as well, and get you your degrees. Let's do an example of each. Okay, so let's say we have 45 degrees and we want to convert that to radians. So we multiply that by 180, pi over 180 rather. That's going to get us 45 pi over 180. And is there a common factor between the two? Yes, there is. You can factor out 45 out of both. So it gives us pi over 4. Now, be careful. Well, don't have to be careful. So if I give you something with a decimal as a degree or something that won't reduce it, then you can either A, leave it in terms of pi over 180, or B, if it's a decimal degree, give me the decimal radians. Okay, it's fine to plug in your calculator. For example, for radians to degrees, let's say I have pi over 7, and we want that in degrees. So I'm going to multiply that by 180 over pi. Cancel the pi's. 180 divided by 7 will get you 25.71 degrees. Yep. Here's the formula for arc length. S equals r theta. What does it all mean? S is your actual arc length. R is your radius. And then theta is, your radian measure. Now, if you're given in degrees, you're going to need to multiply by pi over 180 first, okay? If degrees. If the any of your givens in degrees, pi over 180 is included in this arc length. If not, then just go and plug away. Let's do an example. Let's say I got your radius is 25 centimeters, and then arc length is 15.5 centimeters. Find theta. So plug it in the formula. 15.5 equals 25 theta. Divide by 25. What do you get for an answer? You will get 0.62 radians for your theta. Thanks for watching, and we'll see you in class.